Welcome to your one-stop shop for data science programming powered by businesstrainingai.com.
All right, so let's move forward and build our first predictive model. Building our first predictive model, also known as machine learning. What I need to do now is import from sklearn, from scikit-learn, I'm going to import the linear model subsection, linear underscore model, and then I should say from this package, import logistic regression. From sklearn linear model, import logistic regression. And I also want to import a library that's called stats models dot API formula. Let's do formula.api as SMF. Stats models formula. And we want to use an API. Now, the reason why I'm importing this is because I want to be very clear with you how we designed this model, how we trained this model. And in my humble opinion, the stats models API provides a better view into how we train it. So again, back to Eob's point, do I use a one function black box, or do I do 2-3 lines of code step by step for you to fully understand and have full control over what you're doing, right? You always want to have control. You always want to know what you're doing, right? So in this case, what I'll be doing is creating a logit. Logit equals to. Logit stands for logistic regression, and I'll be using the SMF library and the GLM function. GLM stands for generalized linear model, I think. Generic linear model, okay? All right. And in this case, what I want to do is define our model formula. So formula equals to. Now this formula equals to has to be in single quotes. And our formula will use the binary field as our dependent variable, the one that we want to predict, business success versus business failure. Then we use the squiggle sign to indicate that there is causation. And on the other side, I want to use checking plus duration, maybe I'll do some spacing here for you guys. Checking, duration, amount, age. Let's toss in the co-app. Okay. Now you're going to ask me, why did I decide to use only those 4? Well, then let's put in one more. Let's put in the telephone. I'm using business logic. Now I'm not going to, of course, it could put in all the variables, but that would be a waste of time and resources, right? Because you guys know that telephone is going to be probably insignificant, but we'll see in a moment. Now, after I define this formula, I'm going to do a comma and say data equals to mydf underscore train, the one that we just created with 800 randomly selected clients. Again, mydf underscore train has 800, 80% of my data, 800 randomly selected clients. And then do a comma. And last but not least, we got to specify the family of functions. The family of functions here will come from the stats model dot families, and then we're going to use binomial. Binomial, parentheses. Okay. And after this entire function, after specifying all of this, we're going to say dot fit. Because you want to fit this model. The dot fit specifies that we are fitting this model. Oh, I need to import one more thing. I need to import I need to import pure. Bless you, Thomas. Stats models.api as SM. I just realized that. So please add one more overall stats model API as SM. We need that. Okay? For the family's binomial. And when I click run, this will train my model. This right now is training my model using the API. I'm building my logistic regression using checking duration, amount, age, co-op, telephone, and predicting binary. Okay? So what I'm going to do next is look into this model and identify what is the business insights, or what are the business insights. I do that by I'm gonna print logit.summary. There is a beautiful function called summary that will give you the summary for this model. And when I run this, it'll give me all that I need and all that I want for my logistic. Here are the coefficients for my logistic regression. Here are the p-values for my logistic regression. Those are the two things that you want to keep in mind, right? What we are looking for from this model is the coefficient, and we're looking for the p-value. The coefficient has our business insights, and the p-value has our model significance, or our variable significance. Now, if you know the rules here, any value that's above 0.1 would be deemed statistically insignificant. Now, of course, in finance, we are a little bit more flexible with the 0.1 threshold. We sometimes go to 0.2, but don't quote me on that. All right. Now, out of these values, which of these variables is the least significant, least statistically significant? Artem, do you see the least significant variable?
Well, my initial question was different because I wanted to ask you to show a code just for a sec because mine is not working. I want to compare.
Okay, but before we do so, to keep things organized, which of these variables is the least statistically significant? Which one is the worst when it comes to statistical significance? It's the one with the highest p-value. So which one has the highest p-value?
Telephone.
Telephone, good. And that makes sense, right? Because does it really matter how many telephones you have? Does it really matter on how, can you predict a good or a bad credit card client if you have one or two or three telephones? Highly unlikely, right? So it makes business sense. What we have to do is remove telephone from our model. We're going to remove telephone from our model. Make sense? remove it, because the business case is predicting good, bad clients for credit cards, and the count of telephones, simply put, might not matter. Okay? So what I will do now is go back to my code, them, chance for you, right? Go back to my code and remove telephone from this formula. Okay. Rostislav, got a question?
Yeah, we used range function, but you used like 999, but it doesn't include the last number range function, isn't it? Like
Remember that we are using that range function to get a range of our data. Python starts with 0.
yeah, but 0 and without including the last number, like 999 range function, at least.
Then I should have used 1000, doesn't matter. Okay, maybe I should have used 1000. Yeah, yeah. But thank you for pointing that out, Rostislav. I appreciate that. Yeah. Now let's focus on what we've been doing here. So we removed telephone because telephone is statistically insignificant, if you see on my screen, right? So removing telephone, I'm retraining my model. And again, remember, because you have different samples, you will see different results. You won't see exactly the same results as me because we have different training data sets. Okay. But there is one more variable here that might be statistically insignificant. And it's the amount. The p-value is pretty high. But I want to keep the amount in because there is another issue with the amount. I want to keep the amount in and just drive business insights from the amount. Okay? But keep in mind, a good statistician would probably remove the amount. But we are shenanigans. We're gonna keep it in. Okay. Now, how do I drive business insights from this model? We're going to use coefficients to do that. So the first line. So let's drive some business insights for the checking. I'm going to print np.exp of this coefficient here. The reason why I need to use the exp function is because in logistic regression, everything is in the exponential format. If you were to go deeper into mathematics behind it, into the logit function, you would see that everything is in the exp format. It's a natural logarithm it's an log function, right? So what I have to do now is calculate this. This number here represents, pay attention, ding, ding, ding. This number here represents the change in odds of business success for an extra unit of my variable. So in this case, for every additional checking account, that's my business unit, checking account, the odds of business success go up by 101.5%. Look how amazing this sentence is. For every additional checking account, the odds of business success go up by 101%. If you go to business leaders and tell them this, they will start opening more checking accounts. You guys know that it's not a secret that in the banking industry we have cross-selling, right? Go and apply for a loan. Why don't you open up a checking account? Why don't you open up a brokerage account? Why don't you open up a savings account, right? And yes, it's sales driven, it's provision driven, commission driven. But in our data, we have just learned that if my client has an extra checking account, if they open and fund a checking account, the odds of them being a good client goes up by 101%. That's a lot. is a lot. Who wants to take the second one? Print np.exp. The next one is duration. Duration in months. Duration in months. -1. Who wants to take the next one? What's the duration in months? What's the impact on the odds of business success for duration? Who wants to interpret this? So here's a key finding. Here's a key business finding. The coefficient for duration is a -0.03. How do you convert this to business findings? Come on, folks, use the template. How do I convert this to business insights, this key finding? Rostislav, give it a try.
So it's like for every additional checking account.
Oh, no. We're in duration
Yeah,
now.
we
It's in months. Yeah.
Yeah. The odds of business success
Well,
going
one second.
down by-
Let's slow down. So for every additional month
Yeah, month.
and duration,
Mm-hmm.
it's really important to highlight the business units here. For every additional month and
Welcome to your one-stop shop for data science programming powered by businesstrainingai.com.
duration,